we already produce over 10 million tons of hydrogen in the US right now for mainly petroleum refining and producing ammonia. And so ammonia is really critical for things like producing urea-based fertilizers. So a lot of our fertilizers require hydrogen that we're currently producing from steam methane reforming. And so that's where we use catalysts and heat to generate the hydrogen from the hydrogen that we find in natural gas and methane. Now, going forward, we'd like to decarbonize that hydrogen production process by using something called electrolysis. So electrolysis is using electricity and the voltage associated with it to split water directly into hydrogen and oxygen. And the benefit with that is that now we can use all of our available renewable, sustainable, or low carbon electricity sources, so whether it's wind or solar. So that can help us reduce the carbon emissions associated with getting hydrogen into those different industrial processes and our fuels. So as a fuel, hydrogen can offer many advantages. And when we're talking about using it as a fuel, we're often talking about using hydrogen in a hydrogen fuel cell. So if we compare a fuel cell engine to our typical internal combustion engine, an internal combustion engine burns a fuel to expand gases, drive pistons, drive a vehicle forward. Now, generating heat to generate work is an inefficient process compared to what we do in a fuel cell, where we turn that energy in the fuel directly to electricity, and we can run electric motors that way. And so hydrogen presents another way to electrify transportation at very high efficiencies relative to internal combustion engines. So the advantage of hydrogen, and more specifically a fuel cell versus batteries, is our ability to decouple energy storage from energy conversion. So a battery and a fuel cell have very similar structures. They have two electrodes with an electrolyte in the middle. Now with a battery, the electrodes have these particles that do both the energy storage and the energy conversion. So they convert the chemical energy that's stored in the particles to the electricity that, say, drives the electric motor of the vehicle. Now what happens there, if we want to increase the range of a vehicle, say like for a heavy duty truck, we have to increase the amount of the whole battery system, which increases the weight of the vehicle and takes away from the payload that truck could carry. Now in a fuel cell, it's different in that we have a fuel tank. So the fuel cell does just the energy conversion. That sets, say, the acceleration capabilities of the vehicle. And we have a separate fuel tank that's light, that is just the weight of the hydrogen that we can make larger or smaller depending on the range we need. So we can go to very long range, heavy duty vehicles using hydrogen without that weight penalty that batteries present. So there are a number of challenges we need to overcome with fuel cells and electrolyzers. With fuel cells, it's a matter of cost reduction and increasing durability. So we're looking at heavy duty trucks that need to last 1 million miles or 25,000 hours and be very efficient, right? So what a heavy duty trucking company is looking at is the total cost of ownership. So there's a couple of factors that go into that. There's the upfront capital cost. So we're working on reducing the amount of expensive platinum group metals that are present there. But they also have to look at the lifetime of the vehicle. So we need to make sure that it can last that 1 million miles, 25,000 hours. And that's a significant materials challenge. So how do we adjust or change these materials such that the vehicle is more durable, right? So that can be new carbons, new polymers, new catalyst structures. And so that's an area that we're intensely focused on right now. So both fuel cells and batteries face a challenge in terms of the materials required. So on the battery side, we have challenges of supply chain for things like lithium, graphite, the cobalt that is in a lot of the positive electrodes. In fuel cells and electrolyzers, we also have material challenges, and that is often the cost and scarcity of the platinum group metals that are present there. So in a fuel cell, we use a reasonable amount of platinum, and in electrolyzers, we use a lot of iridium. Now, both of those, like I said, are expensive and scarce. So a lot of the work that we're doing in our lab and in our funded projects is trying to reduce the amount of the platinum or iridium, whether it's a fuel cell or an electrolyzer. This is through engineering the microstructure of electrodes, developing new catalysts that replace some of the platinum and iridium with lower cost materials like nickel or ruthenium and to improve the effectiveness of the iridium. And so that's a current focus of a lot of our work.